Hello again. This is Math 0482 coming to you from the College of DuPage, and the title of this lecture is Radicals and Solving Radical Equations. Let's start with an example, just reminding ourselves about square roots. And so if I ask you to find all square roots of 49, I'm asking you what number, when multiplied by itself, is 49. Now, one square root of 49 is 7, but another square root of 49 is minus 7, because minus 7 times minus 7 is also equal to 49. Thus, the number 49 has two square roots, 7 and minus 7. One square root is positive and one is negative. However, we talk about the positive or principal square root of a number, and it's written with the radical symbol, and I talked to you a little bit in one of the announcement emails about how to do this radical symbol in Braille. And if we leave off the index of the radicand, that's just understood to be 2, or the square root of 2. So the positive or principal square root of a number is written with the radical symbol and the number underneath it. So for example, the positive square root of 121 is 11, because under the radical, 121 is equal to 11, and that means that 11 squared is 121. Now the symbol minus the radical is used for the negative square root of a number, and this is what you did in the quadratic formula, for example. So the negative square root of 121 is minus 11. So minus the square root of 121 under the radical is minus 11, because minus 11 squared is 121. So remember, the radical symbol always represents a positive square root, except if it's the square root of 0, it will be 0. The number inside the radical is called the radicand. The entire expression, radical symbol and the radicand, is a radical. And an algebraic expression containing a radical is a radical expression. And one of these containing, where it is an equation, is called a radical equation. We're going to talk about solving those in the remainder of this video. And similarly, if we were to try to find the cube, fourth, and other roots, we would say that the nth root of a, written with an n in the index area of a, is the number whose nth power is equal to a. That is, the nth root of a is equal to b, means b raised to the nth power is equal to a. So in the nth root of a, the number n is the index, or order of the radical. And then you have the radical symbol, the index, and underneath the radical symbol, it's called the radicand. The whole thing is called a radical. Okay. And it is useful for you to be able to do situations, the first few perfect cubes and the first few perfect fourth powers. We really won't work with anything more than that. So, an equation that includes one or more radical expression with a variable in a radicand is called a radical expression. So examples of these are going to be the square root of x minus 4 is equal to 8. The square root of 5x plus 12 is equal to 3 times the square root of 2x minus 1. Or the cube root of 6 plus x is equal to 27. Now, solving these radical expressions involves a process that we have not talked about before, and it requires careful application. Because, let's start with a very simple example. The equation x equals 1 has only one solution. But if we square both sides, we get x squared is equal to 1. And this has two solutions, minus 1 and 1. So the solution of the original equation is also a solution of the squared equation. However, there's another solution that popped up when we squared both sides, minus 1, that's not a solution. So when solving equations with radicals, we're going to use this idea, but we have to be careful about these extra solutions that are found. And what we will do is, to solve radical equations, we'll use the power rule for solving a radical expression. That is, if both sides of an equation are raised to the same power, all solutions of the original equation are also solutions of the new equation. But please understand, the power rule does not say that all solutions of the new equation are solutions of the original equation. They may or may not be. We have to test them. We call them proposed solutions until we test them. And if they don't satisfy the original equation, they are called extraneous solutions and must be rejected. And again, remember, every solution must be checked with the original equation. Okay, let's do a problem then. Suppose we want to say solve the square root of 3x plus 4, end of square root, is equal to 8. So what we're going to do is we square both sides. So 8 squared is going to be 64. And when I square the square root of 3x plus 4, I get 3x plus 4. So now I have 3x plus 4 is equal to 64. I subtract 4 from both sides. I have 3x is equal to 60. And x is equal to then 20. And we check that in our original equation. And if we substitute 20 into 3x plus 4, we indeed do get 8, so it checks because 20 satisfies the original equation. So the solution set is 20. Here's a problem for you to try. Try to solve the square root of 9x plus 7 is equal to 5. Pause the video and try to solve it. Let's see how you did. You should have gotten 2 for the answer. If you don't get 2 for the answer, make sure you understand what it is, and it's a good thing to ask about when we meet together if you didn't get this answer. But assuming you did, we'll continue. And again, the process is we isolate the radical by itself on one side, we apply the power rule, we solve the resulting equation. If it still contains a radical, we repeat those steps until there isn't a radical anymore, but then we must check all proposed solutions in the original equation and discard any values that are not solutions of the original equation. Remember to check all proposed solutions in the original equation or your answer may be wrong. Let's do another example. Let's talk about solving the square root of 5x minus 1 plus 3 equal to 0. Now in this problem, what you have is to isolate the radical, you have to subtract 3 from both sides. So we get the square root of 5x minus 1 is equal to minus 3. And then we'll square both sides, and minus 3 squared is 9. And the square root of 5x minus 1 squared is 5x minus 1. So we have 5x minus 1 is equal to 9. 5x is equal to 10. And that means x is equal to 2. But when we check it, if we substitute 2 into the left-hand side, which was the square root of 5x minus 1 plus 3, we get 6. But the other side was 0. 6 doesn't equal to 0, so that is false. There is no solution. The proposed solution 2 is not a solution of the original equation. It's extraneous, and there is no solution. And by the way, I note that I could have determined this immediately because I'm showing the principal square root is equal to negative 3, and I knew there was no solution even there. Here's a problem for you to try. Please try to solve the square root of 3x plus 4 plus 5 equal 0. Pause the video and try to solve this. Let's see how you did. Again, for this one, you should have concluded that there is not an answer. There's no solution to the original equation. Now, as we go forward and some of the problems get more complicated, it is important that you remember the following rule for squaring a binomial. If I have parentheses x plus y, close parentheses, whole squared, when I multiply this out, I get x squared plus 2xy plus y squared, because I'm taking x plus y in parentheses times another x plus y in parentheses, and I can distribute or other ways, but I do get a middle term, and it's important that you remember this going forward. Let's do another example. Now we're going to use the power rule to solve the following problem. So we have the left-hand side. I'm asking you to solve this. The left-hand side is the square root of 4 minus x, and the right-hand side is x plus 2. Now the radical is isolated already, so we're going to square both sides. When we square the left-hand side, we're taking the square root of 4 minus x whole squared is equal to, but then when I square the right-hand side, I'm taking x plus 2 whole squared. So that means when I square the left-hand side, I do get 4 minus x, but on the right-hand side, I get x squared plus 4x plus 4. Now this new equation is a quadratic, and what I'm going to do is get everything on the same side and write it in standard form, equal to 0. So when I simplify all of this stuff, I will get x squared plus 5x equal to 0. Make sure you see this. But then I can solve this by factoring. I factor out x times x plus 5 is equal to 0. Now two numbers multiplied together are equal to 0, one of them is 0. So x is equal to 0, or x plus 5 is equal to 0, in which case x is equal to minus 5. Now we have to check each one of these in the original equation. And remembering that the original equation was the square root of 4 minus x is equal to x plus 2. When we check it, we find that 2 does work in that equation. Well, we find out that minus 5 does not work. And so the solution set is only 0. The proposed solution, minus 5, is called an extraneous root. Here's a problem for you to try. The left-hand side is the square root of 16 minus x, and the right-hand side is x plus 4. Pause the video and try to solve this. Let's see how you did. And the answer to you try 3 is you should have gotten 0 is the only solution. Let's try another one. Again, we're going to be squaring a binomial. So the left-hand side in this next problem is the square root of x squared minus 4x plus 9. All of that is under the radical, and that is the left-hand side, is equal to x minus 1. So we're going to square each side. So on the right-hand side, we'll get x minus 1 whole squared is x squared minus 2x plus 1. But when we square the square root of x squared minus 4x plus 9, we will get x squared minus 4x plus 9. Again, this is a radical, and I have to simplify this. Now notice, my dear students, that the x squared is on both sides. It will cancel out, so this is a linear equation to solve. Solving, we will get minus 2x equal minus 8, or x is equal to 4. We have to check this in the original equation, but when we substitute into the original equation, we will get 3 equal 3. So the solution set is 4. Here's one for you to try. The square root of x squared minus 3x plus 18, that's all under the radical, is equal to x plus 3. Please pause the video and try to solve this. Let's see how you did. You should have gotten one solution, and it is x is equal to 1. Now sometimes we have to square twice. This next example is an example of using the power rule, but we'll have to square twice. So we're going to solve the square root of 5x plus 6 plus the square root of 3x plus 4 is equal to 2. Now we want to isolate one radical on one side, and so what we're going to do is we will subtract the whole of the square root of 3x plus 4 from each side. And that will leave us with the square root of 5x plus 6 under the radical is equal to 2 minus the square root of 3x plus 4. Now we're going to square both sides. Squaring the right-hand side, I will get the square of 2 minus the square root of 3x plus 4. So when I expand that, I will get 4 minus 4 times the square root of 3x plus 4 plus 3x plus 4. When I square what was the left-hand side, I will just get 5x plus 6. But the equation still contains a radical. And so what we're going to work to do is isolate the radical term on the right and square both sides again. So we will have, and we're combining some like terms here, 5x plus 6 is equal to, combining like terms, it is 8 minus 4 times the square root of 3x plus 4 plus 3x. And again, we simplify. We get all the terms with x and constants on the left-hand side. We will get 2x minus 2 is equal to minus 4 times the square root of 3x plus 4. And now we're going to divide all the way through by 2. That gives us x minus 1 is equal to minus 2, the square root of 3x plus 4. Now we're going to square both sides. If we square the left-hand side, we get x minus 1 whole squared is equal to the whole of, parentheses, minus 2, the square root of 3x plus 4. So I'm squaring all of that. So that means on the left-hand side, I'm squaring a binomial, and so I will have x squared minus 2x plus 1 is equal to minus 2 whole squared is going to be 4. And when I square the square root of 3x plus 4, I will get 3x plus 4. So at this stage, I have x squared minus 2x plus 1 is equal to 4 times 3x plus 4. So x squared minus 2x plus 1 is equal to 12x plus 16. Or putting everything on the same side, I will have x squared minus 14x minus 15 is equal to 0. Now that means that I can factor this into parentheses x minus 15, parentheses x plus 1, setting that equal to 0. X is equal, the proposed solution then is x is equal to minus 1 or x is equal to 15. But remember, we must test this in the original equation. Now when you check it in the original equation, when you plug 15 into the original equation, you'll find it says that 16 equal 2. That is false. But when you substitute x equal minus 1 into the original equation, you'll get 2 equal 2. So the proposed solution 15 is extraneous and must be rejected, but minus 1 is valid. So the solution set is minus 1. Here's a problem for you to try. The square root of 3x plus 1 minus the square root of x plus 4 is equal to 1. Please pause the video and try to solve this. Let's see how you did. The answer you should have gotten is 5. Again, if you didn't get the answer, you should ask about it and we will talk through it or try to work it again. Okay, now sometimes we're doing the power rule for a power greater than 2. And here's an example. So if we have, and I'm reading the problem now, I'm asking you to solve the cube root of z plus 5 is equal to the cube root of 2z minus 6. Now in this case, my dear students, to get rid of the radical on both sides, we're going to have to cube both sides. And so we're going to have the cube root of z plus 5 whole cubed is equal to the cube root of 2z minus 6 whole cubed. That will give us z plus 5 is equal to 2z minus 6. Solving that, we get z is equal to 11. And we check it. And both sides will give us the cube root of 16, which means it's true. The solution set is 11. Here's a problem for you to try. The cube root of 4x minus 5 is equal to the cube root of 3x plus 2. Please pause the video and give this a try. Let's see how you did. And the answer you should have gotten is 7. Now sometimes you are using the power property to solve formulas, and this is an example of solving a formula from electronics for a variable. And so the equation that we have is z is equal to the square root of L over C. Now we're asking you to solve for C. So what you're going to do is square both sides. When you, so again, the equation was z is equal to the square root of L over C. So when we square both sides, we will get z squared is equal to the square root of L over C whole squared. But the square root of L over C whole squared is L over C. And so then CZ cross multiplying CZ squared is equal to L, and that means C is equal to L over Z squared. Now here's a problem solving for a variable that you can try. And so the problem is, I want you to solve this formula for the variable A. But the formula we started with is x is equal to the square root of y plus 2 over A. X is equal to the square root of y plus 2 in the numerator over A. So pause the video and try to solve this. Let's see how you did. And you should have gotten a is equal to y plus 2 over x squared. In closing, remember, time is precious. Each day must count. Do the math. It will make you strong. I look forward to seeing you soon. Take care.